Okay. Hey, today let me move my face so you can see what's going on. Today is our last acceleration formula. All right. And actually, I think it's the one that I use probably the most when I'm looking at acceleration stuff. And that is the one listed here on the right. I think maybe last time kind of confused. We lost some people on trying to figure out how we derived it. So let's just focus on this as our third acceleration formula. Um, Yeah, and we'll just go with that. Okay. Like I said, this one I end up using the most. Usually these are stats that you know. What this means is delta x. Remember that is our distance. Okay, so that is this delta x is our distance. So whatever distance it traveled is going to equal initial velocity times time. That's almost always going to be zero. Okay, and these equations were almost always going to start off from a standstill. All right. That way we don't have to use the quadratic equation or anything like that. Then that last term is 1/2 AT squared. So 1/2 times the acceleration times time, and time itself is squared. Okay, so that's one big thing to keep in mind is that square that to the second power relates only to time. So don't try to multiply 1/2 times a times t and then square it. Your time is what gets squared there. Okay, so definitely a big day for order of operations. Rather than show how we got to that derivative, let's instead look at the first problem on the assignment here today. I'm thinking you guys can see this. I hope so. So hey, we got someone running sprints in basketball. He starts at 0. That's nice for us. Okay, so I know that my initial velocity is going to equal 0. Perfect. And he accelerates at 2.5 meters per second squared. I know A equals 2.5. Ooh, I got time in there too. Time is going to equal 3.7. How far did he travel? Okay, so remember, sorry, I don't have my camera today to show you by hand. But remember that delta x, which I'm just going to say is distance, equals 1/2 a t, and that t is going to be squared there. Okay, so distance equals 1/2 times 2.5 times, where does that go? Times 3.7 to the second power. Okay, let me pull up a calculator. All right, I cannot do 3.7 squared in my head. Okay, so I get 13.7 is our time squared. Now I can multiply that by 2.5. Now I can multiply that by 1/2. And now I'm getting distance equals 17.1 meters. All right, there's an example of doing number one together using that distance equals 1/2 AT squared. Like I said, that's my favorite formula to use for acceleration problems, and you're gonna be using it all today. Hey, do what I did there. Show your work, write down what you know. If this were me as a student doing the assignment, well, when I make your answer key, it's going to be, I'm going to handwrite it. Okay, so if you can print out the worksheet, or if you can just write down like number one and then show your work there. I think math is so much easier to do by hand in that regard there. Okay, so if you do it by, if you do your work by hand, feel free to just take a picture of your assignment and upload it in the place. Don't have to attach this original document. We'll stop right there today. Keep it simple and just grind through some more physics math problems. All right. Reach out if you guys have any questions.